Welcome to this online video lecture. This is Dinesh, Assistant Professor in ECE Department, Government College of Engineering, Tanjavur. The subject is Communication Networks. We are in Unit 4, Transport Layer. Today's topic is TCP, Services, Futures, and TCP Connections. So these are the concepts we're going to discuss today. Starts with need of Transport Control Protocol, introduction to TCP, TCP services, and TCP futures, the segment format, and TCP connections. See, what is the use of transport control protocol? We are using two protocols in transport layer. The one will be UDP and another will be TCP. This particular video, we are going to concentrate on transmission control protocol, TCP. See, this is a OSI model is a layer architecture. I mean, a lot of layers are available. Each layer has to do some task. The transport layer is heart of open system interconnection. It is a core part. It is an intermediate layer between application and network. If you are a sender side, it has to do break the message. I mean, if you are a sender side, break the application message into segments and pass to network layer. If you are in a receiver side, it will be reassemble the segments into messages and pass to application layer. So what is the use? If you talk about the use of TCP or UDP, see, we are running different applications in host. In the sense, multiple application at the same time we are accessing the application and exchanging the data from one application to another application. So a lot of integration is going on. So for that purpose, we need to identify the application through port numbers. Through ports, we are going to identify the specific application used by the user in the source side as well as the destination side. So that will be done through transport, control protocol, in the sense TCP. Not only that, I think if you talk about TCP or as it providing a connection, it providing a setup, sending a data for host to destination is done in transport control protocol. The transport layer has a critical role in providing end-to-end communication to the directly application process. So it creates 65,000 ports so that multiple application can be accessed at the same time. So it takes the data from upper layer and it divides the data into smaller packets and then transmit them to network layer. See, the purpose of transport layer is about, we know that process to process, application to application. And we say that the packet will be here, the segment have numbers, and that will be divided with the help of port numbers, with the help of sequence numbers, we can reassemble. So these things are happening. So there are three protocols we are using, that UDP, TCP, and SCTP will be used. And so that will be major part, will be transmitting that data, application data, and find out the proper destination through transport layer protocols. So what is the use of TCP? The TCP relays on network layer and serves on application layer. So transmission control protocol, it provides a connection oriented service. It provides reliability, and it having a connection setup, and it having three way of handshaking before sending the packet, before sending the data, and it packetizing the data through some acknowledgement number, sequence number, port number. So these things are done in TCP, and they have a separate segment format. There they have a flags and they have a control fields. So a lot of things are available in TCP, like error control, checksum, flow control, congestion control mechanism is all adapted in TCP, and it will be have a separate protocols. They have separate bits allocating for in the format segment format in TCP. See, it can easily discard the corrupted packets, and it can also possible to retransmission, and so the connection setup, data transfer and termination. These things are happening here. We'll see one by one. See, the main functionality of the TCP is to take the data from the application layer. Then we know that. Then it divides the data into several packets. And another important factor, it providing a numbers for each packet. And finally, it transmit the packet to destination. In as I said, in the other side, it will do reassembling. It's also possible. See, if you take a small example about TCP, we have a HTML file, and particular HTML file is going to use that hyper transfer protocol. I mean, and I'm taking example. So TCP is a client server model. Server sends the HTML file to the client, and that using a hypertext transfer protocol. So then hypertext transfer protocol program layer giving a request to TCP and to set the connection, then send the file. Then what TCP is going to do is going to divide that file, the whatever HTML file we have given, that will be divided into packets, and each packet, the segment will be given by numbers. And after giving the numbers, finally we forward to IP, I mean that internet protocol layer, to deliver. Though each of the packets in the transmission has same source, we have a same source. I mean, if I have the HTML file, the server is going to send that HTML file to client. We are having a same destination, same IP, but that file will take the divided file. That small packets will take different routes through different nodes or a router. It will take, and finally it will receive that destination. Then we do a reassembling and get the data, get that particular HTML file in the server. And importantly, and TCP provide a acknowledgement. What we are receiving the data, we are receiving the corrected data. So that will be happen TCP. The TCP having a window, and sender, receiver, they have to exchange the information through packets with the information like acknowledge number, sequence number. Through it has to be done. So they have a duty of one small file in a server that will give to small protocol. That protocol needs the help of to TCP. Then TCP take care and they divide that file and give back to IP. Then IP will take care of destination area. I mean, then it give the application, give the correct application and identify the correct port, and then give the data to the destination part. So this is a small example of transmission control protocol. As I said, it is a connection oriented service. Again, I will take client server example, and if we have a setup like a client process, then they have to send small source client transport layer. The receiver side, we have server transport layer and server process. One will act as a sender and another one is act as a receiver. Before starting that connections, we need to provide a setup like circuit switching and all other handshaking. We have to set three-way handshaking that will be done, synchronizing, acknowledging, and for setting the packet. Once the connection will be established, we are sending the message through the packet that will be received from the receiver side, I mean the server. Then we are sending another packet. That packet is not received at that time. I mean, the second packet, the message 2, message 1 is not yet received. Before that, message 2 will be received. If you take in a connectionless protocol, connectionless service, it will be going on like UDP. But here, the packet, the message 2, the packet 2 will be put in hold. because the packet 1 still not yet arrived. For the purpose, the message 2, the packet 2 will be hold. Once the packet 1 will be received, then both will be, that order will be followed in the server side. Message packet 0, packet 1, packet 2. Suppose if the packet is file, we are going to retransmit the file. So we are waiting for the particular packet. Then before that, if you are getting another packet, that will be put into hold. So this is a connection oriented service examination. Then after that, it will be terminate the connection. So if the window is full, it automatically discarded. It may happen and we will again retransmit the packet is also possible. But this case, we are talking about multiple packets. First packet in this particular time and second packet in the particular time. If the second packet comes late, it will have a place and it have to form the order till that second packet will have to reach the destination. Is done by server side TCP. So what are the services the TCP available? So in TCP, they have a process to process communication. In the sense, they have a transfer of data take place between individual process executing on an end system. This is done using port number or a port address. That's why we identify the application. This is a 16-bit size. And in TCP, it is stream delivered service. It is a stream of bits, stream oriented protocol. Whereas UDP is a user datagram protocol. See, TCP is having an imaginary tube will be there in a source side and the receiver side. So that allows the sending process to deliver the data as a stream of bytes and allow the receiving process to obtain the data as a stream of bytes. So stream of bytes is done in TCP. And we know that it is a full duplex, bidirectional. Both the direction we can send the communication will take place at the same time is possible. Connection oriented service, that is an important factor in TCP. It's providing first connection establishment, data transfer, and connection termination. So these things are happening in oriented service. It's not physically connected. It means during the transmission of resources will not be reserved and the segments will not follow the same path. So that not will be happen to reach the destination. But it is a connection oriented in the sense the segments will arrive in order. That's we previously we discussed about that example, arriving in the order of packets with the help of sequence number. Reliability is an important factor in TCP because UDP doesn't have reliable communication. It won't send reports. It won't send acknowledgement. Not only that, it's retransmission, error detection, and attempts to recover a lost packet, corrupted packet will be retransmitted. Acknowledgement policies are there, and each packet or data they are given a byte number is possible. You can send the byte data. The stream of data will be sent. The byte number given to each data and the sequence number is given and acknowledgement number. So that are ensure the reliability through these things will done the reliability. And we do multiplexing because multiple applications and multiple sender receiver, we have to respect the number of logical connections can be established between port numbers or a physical connection, single to multiple, multiple to single. Multiplexing and demultiplexing is done in TCP. And the important factor is the TCP feature because the numbering system in TCP, as I said, we have given a sequence number, port number, acknowledgement number, some number theory is going on. Whereas the TCP software tracks the segments being transmitted or received. There is no field for a segment number in the segment header because we are using a sequence number and the acknowledgement number. These two fields refers to byte number, not a segment number because we are giving a sequence number. What is byte number? TCP numbers all data bytes that are transmitted in a connections. The numbering is independent in each direction. It's not necessarily starts with 0 or the random number it may be. They have stores them into, they have a buffer also. So these things are there. See the sequence number, after the bytes have been numbered, TCP assigns a sequence number to each segment that is being to send. See, for example, I'm going to talk about the segment 1. They have a sequence number for 10,001 is the sequence number. In the sense, the range is, the data range, the byte range is 10,001 to 11,000. The 10,001, 10,002, these are named as byte number. The starting byte number is named as sequence number. This is done here in, that sequence number is referred to segment 1. So the sequence, using the sequence number, we can reassemble or reorder the packets. Segment 2, if you have the same examples are given here, the sequence number is 11,001, the range is 11,001 to 12,000. That's very important. What is acknowledgement number? When the connection is established, both the parties can send and receive the data. After receiving, they can put a sequence number and get a packet acknowledgement and control fields, or transmitted to source to destination. And each party as a source or destination also use the acknowledgement number to confirm the bytes, what are the data bytes we will receive. The next part is TCP segment format. So we have a header. The whole header have a lot of things, and we have a payload part. We have source port address, the application part, source port address, destination port address, both are 16 bits. They have a sequence number, it's a 32-bit number, and we have acknowledgement number, it is also 32-bit. We have a header length will be 4 bits, a reserved bits, and we have a flags like urgent, pointer, acknowledgement, push, reset, synchronize, fin. To terminate, we are using fin, like window size, checksum error control, and we have urgent, pointer 2, and we have padding. If it is a less bit, we need to add 0. So that type of things are available in that TCP segment format. So the format will be classified here, and each part will be individually given. Source port, it defines the port of the application which is sending the data. So this field contains source port address, which is 16-bit. So port address is very important. That port number is used to identify the specific application run on different host. Destination port, it defines the port of application on the receiving side. So this field contains the destination port address, which is 16-bit. Sequence number, see the sequence number, this field contains a sequence number of data bytes in the particular session. And acknowledgement number, when the acknowledgement flag is set, then this contains the next sequence number of the data byte. We have a clear example in the coming slides. They will have a discuss about the sequence number and acknowledgement and how they are providing, as well as the sender side and the receiver side. If you see that the receiver receives the segment number, for example, it is X, then it responds X plus 1. So that is prior acknowledgement. It's not like prior acknowledgement. They are waiting for a next packet. They're giving acknowledgement for, we are waiting for next packet. So that will be done in that TCP. Header length, we have 4-byte words in the header. The size of header lies between 20 and 60 bytes. Therefore, the values will be lie between 5 and 15. They are reserved bits too. We have a flag, 6 control flags are used. We are using urgent pointer. If it is set that the data process is urgent, we need urgent process like push. If the acknowledgement, if acknowledgement is set to 0, then it means the data packet doesn't contain an acknowledgement. Push, if this field is set, then it requests receiving the device to push the data to the receiving appliance without buffering it. We don't want buffer. We need a immediate transfer. Resetting of restart a connection, and synchronization, it is used to establish a connection before sending the payload. We are going to synchronize the connection setup. And fin, it is used to release a connection, and no further data exchange will happen. And we have window size. It is a 16-bit field. It contains size of the data that receiver can accept, and this field is used for flow control between the sender and receiver. Once the flow control is very much important, the data rate will be adapted through flow controls, and buffer is very important part. Then only we can send more data. The value of the field is determined by the receiver. Checksums is used for, it is optional in UDP, but it is mandatory in TCP. And urgent pointer, we have urgent flag to set that. And we have options like padding part. Option fields represent 32 bits. If this field contains the data less than 32 bit, then padding is required to obtain the remaining bits. TCP connection. Finally, we are coming to TCP connection. See, if you take this example, we have a client process, server process, and the client area is, that is, we say that active open. We get before connection. We're going to initialize the process. We're going to request the server to set up a connection. That is active open. Passive open is waiting for that request to send the data. So first, this is the message. This is the diagram to represent the connection setup. The first packet, the segment will be sent through the sequence number. It consumes one sequence number because of the data packet, but we don't have a data, but synchronization part. But it consumes one sequence number. It's like random number, like sequence 8000. That will be sent to the receiver side, server side. Then server send that sequence number, and then they have consumed one more sequence number, one more packet. That particular sequence number, and they acknowledge the previous packet sent by client. So that's why it is named as what sequence number we are given, that will be act as a acknowledgement number in the receiver side. Acknowledgement number is 8001. In the sense, we are waiting for we are acknowledging the first packet, what we are sent, and we are waiting for the next packet, 8001, the sequence number. So that they are given in the acknowledgement number. Here, sequence number, that will be given an acknowledgement, that is followed here. And they consume one sequence number. What they are doing, they're giving acknowledgement and synchronization for connection setup. So that into sender side. Then the client, what they are given another sequence number, what we have waited, like acknowledgement 8007 is awaited. They send a new sequence number with the acknowledgement, but there is no data. We're just acknowledging that whatever data we send it, like sequence number, we are waiting for the next packet. Like that's why we're given in that acknowledgement. See 15,001. This is a sequence number here, 15,000. If you are next, what we are saying that we are acknowledging the 15,000 and we are waiting for 15,001. So that will be given to connection and server side. So this is a basic setup for synchronizing, giving request for connection and giving acknowledgement. Then after getting the acknowledgement, the connection establishment will be happen. Data transfer. Once the connection establishment is happened, we are going to send the data. For example, I'm sending a sequence number 8000. As I said, we talk about byte and byte numbering, and that range is 8001 to somewhat it's 9001, whatever it is. Here the data byte range is given here. Whatever data, that may be HTML file or a specific application, whatever it is, 8001 to 9000. That is a byte number we have for the datas. We are giving a byte number. 8001 is a sequence number. Starting of the byte number is a sequence number. And we are acknowledgement is the previous one. I mean, we are acknowledging the previous connection process. We have acknowledged that 50,001. In the sense, we are waiting for next packet, the receiver side. Next, again, the receiver, sender client, we are sending another packet. That is possible in TCP. Sequence number 9001, because we are going to send 2,000 bytes in 2 packets segments. Because once the connection is set up, the server side is always ready to accepting. If the window fill, they have a problem. So that is a sequence number 9001, because you see that last data will be 9000. We are starting the new sequence number 9001 to 10,000. We are sending 2,000 bytes in 2 packets. They have acknowledgement of 15,001, the last acknowledgement of the receiver side. Now receiver sending a request, they are acknowledging the total to 2,000 bytes, like here. Because we are acknowledged number is 15,000, then the sequence number starts with 15,001. So we are new packet 15,001 is given. They have a sequence number. They are arranging. We are getting the data. We already got the data to 15,001 to 17,000. Total 2,000 bytes we are received. That will be acknowledged in receiver side. Then they are giving a new sequence number. The acknowledgement number is 10,001. So we are giving a sequence number 10,001. The acknowledgement is 7,000. We see here 7,000 data is over. 17,000 is a data byte will be get over. We are giving acknowledging that next is data. If you have available 17,001 packet, I mean that acknowledgement number, but we are not sending any data. We are just sending acknowledgement because we don't have any data. The whole 2,000 bytes is sent and we are getting acknowledged. And if you have any data, and if you have any packet want to send, that will be given here. We are waiting for that packet. That will be referenced here, this particular last packet. Totally, sender side, we are giving 3 packets. 2 packets we have a data, third packet we don't have a data. In receiver side, totally we have only 1 packet. So that will is to acknowledge with the 2000 bytes sent by the client. What are the advantages of TCP? The TCP, we know that TCP provides a connection-oriented service and it's a reliable service, which means that it's guaranteeing the delivery of data through some acknowledgement number or sequence number, port number. We have a flow control mechanism. We have a sliding window protocol technique. So a lot of techniques are there to providing a reliability, connection-oriented service, and it will be ordering the packet in the receiver side. It's all possible. What is the drawback of TCP? See, it increases a large amount of overhead as each segment get its own TCP header. The TCP header is a large information. We are putting a control, we are putting a flags, we are putting a sequence number, port number, header length, and a lot of things are overloaded, and the router has to get the more things, more header data, the data about the particular segment getting higher. So that makes the processing delay will happen because they have a lot of data will not be have to updated by every router present in all the nodes in a networking side. And then we need to compare the last video session we discussed about UDP, user datagram protocol, and TCP protocol. We're going to just compare the TCP versus UDP. Starts with the types of connection. It is a connection oriented protocol, whereas UDP is a connection less protocol. We have seen examples how we are connection establishment is happening. A reliable, and TCP is a reliable protocol, provides assurance of delivery and getting reports. UDP is not unreliable. It is it's not unreliable and not given any guarantee or report or acknowledgement to the sender. Speed, TCP is slower compared to UDP because UDP doesn't get more detailing in the packet, whereas TCPs get more detailing and more data to fill up, which is very faster UDP. And the header size size of TCP is 20 byte. Is very less. Size of UDP is also 8 byte. That gets router as a very easy job to do. Applications, TCP, it's very secured and reliable applications like military services, web browsing, electronic mail. These are the great examples of TCP. Whereas UDP, we have video streaming like voice over internet protocol, game streaming, video and music streaming, live data. So that type of data doesn't need acknowledgement at all because a lot of data needs to come to sender side as well as receiver side to accommodate that. So we can't send each data for acknowledgement and all. So this is the comparison of TCP versus UDP. So it depends upon the application. You have to choose the transport control protocol. So this is the last part. I mean, we're going to conclude that this particular video session, and we discuss about what is the use of transport layer protocol, and we concentrated on transmission control protocol, what is use of layering, and what is the intermediate layer of transport layer in sender side, dividing the packets, segments, packetizing, numbering. So the number given to byte number, acknowledgement number, port number will happening in TCP connection. They have a lot of services. TCP provide a lot of services, point to point, and they are given a lot of services for applications, port numbering, as well as they have features, lot of features in TCP, and it's very reliable. And they have a connection establishment process. They have a data transfer. We discussed about data transfer. We've seen an example of TCP, how web server sends a file to hypertext transfer protocol and how it will be handled over to TCP, and TCP is handled to IP to reach the destination. So this is about TCP. It's a reliable protocol and guarantee for your data delivery. Thank you.